This is LifeLine. Everyone's instinct for a safety critical AI task is the same: collect data and fine tune it. We did the opposite. We trained nothing. We took a frozen open source model and spent compute at inference time instead, then verified each and every answer. The result is a hands free first aid assistant that's about 98% verified with zero training. It's like a voice agent and it helps you during critical times whenever you need first aid. So, what's the real problem? Here's why it really matters. In a real emergency, you can't go ahead and read a web page about how to save a patient, how to do CPR, how to perform resuscitation. You cannot watch a YouTube video. They're gonna throw up some ads. You're gonna have to skip those ads and watch them. So your hands are busy, you are panicking, and the wrong instruction can kill you. Open models are almost good enough, but mostly write is unacceptable for CPR or choking. So the question we asked, can you make a frozen open source model safe enough without training it? That is our entire thesis. Our bet is the theme of this particular track. Build as if compute is free, then verify. Keep the model frozen, spend inference time compute to generate many candidate answers, and use a deterministic verifier to keep only the ones that match the official protocol. The model stays dumb. The system becomes safe. How it works? We recognize the emergency. So we generate n candidate answers using two compute knobs, denoising depth and best of n, and check each one against the protocol. Required steps are present, forbidden actions are absent. We speak the first answer that passes or fall back to the official protocol. It never speaks an unverified step. That is more important because LLMs don't do that, Google searches don't do that. We never speak the unverified step. So let me just go over to the app and show you. So this is how the app is gonna look like. He collapsed and isn't breathing. Immediately as you see, it tells you call 911, get an AED.
120 per minute, about 2 inches deep.
You have to follow all these steps. You either do this or you start over and you tap over here. Hey, my dad suffered a severe heart attack right now. Tell me what all I should do to save his life.
Heart attack. Call 911. Emergency services. Right away and say you think it is a heart attack. Help the person sit down. Keep calm and still. And loosen any tight clothing. If they are not allergic to aspirin and it is not otherwise.
So if this is connected to Lambda Labs GPU or if it is connected to some open source compute at the moment, then these answers will be further refined because we are using open source Gemma model that Google released 10 days ago. And what Gemma model does is it shows you all the answer, all the text at once instead of predicting the next particular character or word. And it reiterates the answers again and again so that it is more detailed and it becomes more efficient as time goes by. Moving on to the next slide. So if you see over here, so what is particularly novel? The key insight is why a deterministic verifier, not an LLM judge? Because we are far better than LLM judges. ChatGPT is going to guide you in the wrong direction. That's why people are complaining that, don't go ahead and ask ChatGPT about your symptoms and ask what problem you are particularly having. Best of N is an adversarial search. Sample enough and you will surface a confident, fluent wrong answer. An LLM judge gets fooled by that and flip-flops run to run. Our rule-based verifier doesn't care how good those pros sounds. On a 42 case adversarial set, it caught all 12 fluent but dangerous answers with zero leaks, and it's basically free, which is what lets bets of N scale. So if you go ahead and look at impact that we have, so it's like I just showed you all of this. He collapsed, he's not breathing, it's gonna throw you an answer. If you it's based on what you're gonna say and it's gonna immediately come back. The response time is like super fast. And if you work this at scale, why this matters at scale? The verifier is the product. Point it at any task with a checkable protocol, code with tests, structured, extraction, compliance, and frozen open source models become safe to ship. And it gets cheaper and better as compute does, which is exactly the curve this hackathon is betting on. So a frozen open source model, inference time compute, and a deterministic verifier. 80 to 98% verified,